I'll try to write a recursive algorithm for the question. So the question is here: how do I find the clusters which are disconnected? So diagonally they are not connected, only horizontally and vertically. So this is one cluster, this is another cluster, and this one is connected through this horizontal one. Is also accepted as one separate cluster. So there are three clusters in this matrix. So I'm gonna try to write a recursive function to find it. There's other ways, of course, but we'll try this one. So for that, I will use a memorization method, which will basically set those who were visited already. Let me call my function dfs call. So I'll for sure insert both of these matrices, the references of the matrices, so there will be only one matrix that all functions will be using. Then what else? I need to send the row and the column index to each number inside. So we have here n as a row number and m is column numbers. And if I need something else, I'll definitely write it here. So again, at some point in my function, I will be again calling my first call, and of course I'm gonna send those things inside. So I guess I need to trace through all of them. So let's say this is my main function here, and inside here I'm calling my very first function again with hm and I'm calling it with 0 0, right, with the very first number, and of course with 4 and 5, which is my rows, and it's actually 5 and 4. So let's call this as my first function call. So this is my one. So what I want to do is I want to go to all these sites, 4 sites, to check if there is one neighborhood 1 to this one. So I go here. In this case, left is no one is there, up is no one, bottom no one, and on the right, only on the right we have another one, right? So what I do here, I say since I am on 1, so it comes here as 0 0 0 0. So I need to first figure out which conditions I have to have. So suppose this is my suppose this is my value at 0 0. So this value will be 0 1. This will be 0 minus 1. This will be minus 1 0, and this will be 1 0. So those are the things that I need. And also when I am entering each function, since I am already visiting my function, I need to set uh, my hash matrix to 1. So that means I'm visiting this already, right? So this is will be up, and let me move it a little bit down right here. So in order for me to enter any of the sites, I need to have a case, right? Because if I enter here when it's not 0 here, I know no point to enter it if it's 0. So the very first check would be if the number, let's say, let's go clockwise. First we try this. That means the number, so which one is r minus 1. Actually this will be later. So we need to first check if it's in the range. So the row should be bigger or equal to 0, and the row should be less than n. The same we need to write for a column. Column needs to be bigger or equal to 0, and column needs to be less than m. And then we can, after that, we can check if the value is 1. So in which case our first value is this one, r minus 1, and this will stay as 0. Okay, so what else we need here? Let's finish it here. And so if this is the case, then go to the next, call the next neighbor number. So here we are passing r minus 1 and c as here, and then also all other stuff, and m. Okay, and m. And so we do all these. I guess I need to copy it. Let me copy it. I will copy it. Three more times. So, and here I'm just changing those values. So if we take this, for example, it will be r c plus 1, right? And we of course change these values as well. C plus 1. Okay, what else? We come here, you say r plus 1 and c, r plus 1 and c, and then we come here, it will be r c minus 1, r c minus 1, r c minus 1. Okay, so we were able to access all these queries. And do we miss something else here? Let's see. Not really sure. So let's test. So suppose we are entering our first call, which is 0 0 0 0. We come here. And we check. So we are setting this to 1, and then we enter the right row. If we enter the right row, actually I didn't complete this code. This should be 1 in order for me to enter, right? Should be 1. What else? But I'm not using these values here. No, there. I'm gonna use it here. So if I'm calling this one and this call is already visited, let's say, that's why on each call, if it's unnecessary, I don't need to call this function outside, and we will be calling it for each number here. And if you will call it for each one, it's gonna be a really long process, so we need to eliminate those who were already visited. So, and also we need to eliminate those who are 0, right? So we say if matrix RC is not equal to is 1, and at the same time HRC is 0. So either this is 1, then visit, but then if it's already visited based on this hash map, then don't visit it. So if this is the case, then call this function. Otherwise, don't call it. MHRC NM. Right, so if it comes to here, it would be already visited from this part. So, and if it comes to the second row, so let's say it comes to here, it normally should printing this, but then this one is set and it will skip it. So it's not gonna run it. It will run this, but it will skip this one. It will skip the next one because it's 0. It will skip 0 3. It will skip 1 0 1 2 and 1 1 1, and only it will run 1 2 1 2. And I guess this is how we go with it. And let me check my previous solution. So our purpose was to count it. So I suppose we are putting loop here, and we only count inside each of these calls. m is equal to 1 in each one of these calls, and I guess that's it. This is what we call. So let me think one more time. If it goes inside here, I guess, okay, yeah. So this will be our main recursion function, and the all time would be n times n, so n squared, n times m, I guess.